In this video, we are going to continue our discussion of converting between coordinate systems. In this video, we're going to focus on converting between cylindrical and spherical. To do this, though, the quickest way to do it, unless you just want to build formulas, and we typically don't because it's more to memorize, more to work with, we can actually just use rectangular as a middle ground. Meaning we can go cylindrical to rectangular, rectangular to spherical. So let's work through some problems and maybe figure out some ways to get around it. So I'm going to list out what we have. I like doing that because it reminds me of the formulas I need to use. Cylindrical. So this is a cylindrical point. That means we have rho, which is 4. We have theta, which is pi over 3. And then we have z, which was negative 4. Right? Spherical. We need a rho, we need a theta, and this is not a rho, that is an r, right? R is 4, not rho. Theta is going to be pi over 3, that's the same, and then we're looking for a phi. I apologize for the r. Some of you guys were like, oh, I messed up. There it is. So to get one from one form to the other, I know that rho is x squared plus y squared plus z squared. Now you're thinking, well, we have a z, but we don't have an x squared plus y squared. But I know from the formulas above, you look through them, that this x squared plus y squared is r squared. So we actually do have a formula that we can use. So rho squared is 4 squared plus z squared is negative 4 squared. We're going to get 32. So that means that rho is the square root of 32. We can rationalize this to 4 square roots of 2. So we have 4 square roots of 2 for rho. That's just using this formula and then changing x squared plus y squared to r squared. There's my new formula right there, right? So we could, if we wanted to, there's my conversion from cylindrical to spherical. Now, the next thing, that's going to be cosine of phi. We have this formula. It's z over rho. But we can plug stuff in for that. Let's do that and find phi. So that is z is negative 4. Rho, we have that. That was the missing link in this formula that we now have. So cosine phi is negative 1 over rad 2. This is the same thing as negative 2 over rad 2. So that means phi, and we're looking for, those are the over 4 angles. That's going to be a 3 pi over 4 if we match the first point. Let's do that. We also have another value that could work. We have 7 pi over 4. Let's look and see why it would not be that. This is r is 4, so if we draw a coordinate system, okay, r is 4. And then pi over 3, that's going to put me somewhere in here, and then down. So it's actually below and that is in, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. That's an octant 5. So we need to make sure our answer is also an octant 5, but we don't even need to consider z. We know it better be the same thing that's in quadrant 1. Well, the only thing that's going to work for that was, we already have that angle, it's pi over 3, but now we're dealing with, we need phi to drop down from the positive x-axis. Well, if I need it to be down below, it's got to be big. It's going to be way down there. So that other angle is not 7 pi over 4, even though it's really tempting, but that's like way around. That's past pi. It has to be this. We could also think about that phi is defined between these two values, which means we would not get this. So it's 3 pi over 4 because we want it to be the phi to go all the way down below into octant 5. So this is 3 pi over 4. I have one more example going the other way. Let's write down the answer here, spherical, and the point is 4 rad 2, pi over 3, and 3 pi over 4. All right, we have one more example here going the other way. It's spherical to cylindrical. So let's write out our spherical points. So this is spherical. We have rho is 5. Theta is pi over 4. And then phi is 3 pi over 4. And we're looking for cylindrical. Cylindrical has an r, has a theta, so we can grab that, same thing. And then it has a z. So we just use formulas. I have r equals rho sine phi. That's on that list. So r equals 5 sine 3 pi over 4. All right, sine of 3 pi over 4, that's up, it's y, it's going to be positive, and we know all pi over 4s for sine and cosine are rad 2 over 2, so that means this is 5 rad 2 over 2 for r. So let's write that in here. And then we have one more thing, and they have a formula for that too. Good one to write down. So z equals 5 cosine, and then phi is 3 pi over 4, so we plug that in. Well, cosine is going to be, it's to the left, because that's x. So this is actually going to be a negative root 2 over 2, which means my answer is negative 5 root 2 over 2 for my z. So my answer in cylindrical is 5 root 2 over 2 pi over 4 and negative 5 root 2 over 2.